Let's go into some details on analog sensors. We're going to talk about what are analog sensors. We'll go over some typical underwater sensors, and we'll cover what sensors we'll build in this course. It helps if we know a little bit more about analog sensors. Analog sensors are devices that convert an external stimulus to a continuous signal representative of that stimulus and can be monitored or sampled. And in our case, we're going to be monitoring or sampling it by the Arduino. And the analog sensors will scale that stimulus to a value that we can use. In our case, the Arduino will scale that sensor value between 0 to 1023 or 1023. An analog sensor may output a signal as a voltage, a current, or a multi-bit digital value that is already converted, and whatever that output is, it will be representative of the analog signal at the very moment it is sampled. Because analog signals are time dependent, the values sampled will change each time they are sampled. What are typical analog sensors? Well, how about sound? A hydrophone. This is a microphone designed to be placed in the water and listen to sounds while it's submerged. We just can't stick any microphone underwater. The conductivity of the water will short the microphone out. So the simple process of waterproofing a microphone so that it can go underwater can create a hydrophone. Temperature. We monitor the temperature of the water, and underwater temperatures can range from below 0 degrees centigrade to well over 400 degrees centigrade if you happen to be measuring the output of a hydrothermal vent. Conductivity. It's a measurement of the water's ability to conduct electricity, and increased salinity is associated with increased conductivity. Their conductivity sensors can get quite complicated, extremely complicated, and we'll be doing some very simple conductivity sensors. Pressure and depth. Obviously here, as the depth increases, the water pressure will increase, and we'll use water pressure sensors and monitor that pressure, and then we convert that pressure to a depth. A magnetometer, a magnetic anomaly detection. And the presence of any metal objects underwater will distort the magnetic field around that object, and sensors can detect that distortion or variance. And so you'll read values and you can detect and plot those values as you get closer and farther away from that disturbance. Light. Transmissometer is used to monitor water clarity and suspended solids in the water. And the transmissometer data is often coupled with pressure data so that you can return values that are correlated to depth. And then don't forget about system monitoring, your ROV health and status. It'd be nice to know what the voltage is at the end of the ROV tether, a current draw by the thruster. Both of these together will tell you if you have problems going on in your ROV. If you have a thruster that happens to be caught or entangled in underwater growth, the current drawn by that thruster will suddenly start going much higher than normal. You can monitor current and detect when you have a problem with the thruster. Monitor your sensor bus. A lot of times you'll create a separate sensor bus voltage out there to keep it separate from your thruster voltages. This would be a nice filtered and quiet system bus so as your sensors are not disturbed by the variations caused by the thrusters. You can measure the temperature of your electronics housing. Again, this can give you an indication of something going wrong. If that temperature starts spiking, more than likely you have a problem inside there. And of course you want to use methods of water detection. You can do that by conductivity and in many cases pressure changes. What kind of sensors will we be building in this course? Well, we're going to be working with multiple different types of temperature sensors. We'll be looking at a few different types of metal detectors. We'll be looking at light. Create a transmissometer, a very crude transmissometer. We'll be doing some system monitoring, specifically voltage, and we'll talk about how to monitor current. And doing conductivity, we'll make an external water conductivity sensor, again very simple, without the temperature compensation and depth compensation, and build a simple ROV water leak sensor. And of course we'll be making a basic hydrophone.